or they'll go through the recording. So welcome everyone to the Tom class. As you know, from the last class, we are studying the gear and gear train topic. Till now, we understood how we have given some introduction about the gears, how gears works, and we also understood the different types of gears, terminology of the gear, law of gearing, okay, and then we have started the gear profiles. Okay, I have given a small introduction in the last class that the profile has to follow law of gearing. So there are two profiles which are commonly used. One is cycloidal profile and another one is involute profile. Okay, I have also given you introduction. What is a cycloid? Cycloid is a curve traced by a point on a rim of a circular wheel as the wheel rolls along a straight line without slipping. So you can clearly see here on the left hand side figure number A, we have a wheel which is rotating, okay, which is rotating on a straight line. Okay, then we call it as a, then the curve traced by that point on a circle is called as cycloid. And you can actually roll that circle not only on the straight line but also on the let's say a pitch circle. Okay, so you can here this is a pitch line, you can replace that pitch line with a pitch circle also. Then the terms are called as epicycloid and hypocycloid. Okay, because we can clearly see either we can rotate the circle on the pitch circle or below the pitch circle. Okay, so depending on that, we have two different names for it. One is epicycloid and another one is a hypocycloid. Okay, so this is how you can see we can construct gear teeth from the cycloidal curve. So I'll just show you here the point P to A dash is a epicycloid. Okay, again here A to P is also epicycloid. Then B dash to P dash is hypocycloid, and B to P is again the hypocycloid. So two hypocycloids, two epicycloids gives us the cycloidal curve. Okay, or cycloidal profile for the gear tooth. So what we can understand from it is that four different curves are required here in order to generate a single gear teeth. Okay. So in the last class, I have not shown you these diagrams, so you can just go through it. So the next profile is the involute profile. Okay, I'll go to the next slide. Okay, what is involute? Involute curve is a locus of a taut string as a string either unwind or wind around the curve. So look at this point. Okay, so as you unwound or let's say unwind this string from this circle, this is how the curve it will take, right? So similar curve you can generate and you can make a gear teeth out of it. Okay, so like this, for example, you can make a involute gear teeth. So only in this case you can see that only involute profile is used, whereas in case of cycloidal curve, means we need epicycloids as well as hypocycloids in order to generate involute curve, in order to generate the gear profile. Okay, and here what we are using, here we are using just a involute curve in order to generate a tooth profile. Okay, so comparatively this is easier to manufacture, or this is simple than that of cycloidal profile tooths. Okay, so we'll not go into the details of how it is generated and all. That is not part of your syllabus. You should be aware that which profiles are used to make the gears and what is their comparison. Okay, how we can how this involute curve or how this involute profile is different from that of cycloidal profile. Okay, that is what expected from you. So yeah, in general you can see this is how it looks. So on right hand side you can clearly see the cycloidal tooth profile looks something like this. Okay, something like this. Okay, so at the base you can clearly see here uh, the base or uh, the base is a little bit spreading. Okay, whereas in this case the profile looks something like this. Okay, so means the edges at the base are coming together. Okay, so I'm trying to just draw this part and this part here to make you feel understand like how exactly how they look. So here this is epicycloids, these two are hypocycloids, and these two are, in this case, these are the involute tooth profile. So just by looking into it, we can judge whether that gear is made by involute tooth profile or a cycloidal tooth profile, because we can clearly see here um, a convex part and then concave part in case of the cycloidal profile, whereas in case of involute profile we'll just have a convex part. Okay, is it clear till this? Can we go to the comparison? Yeah, so let's try to so we understood how it basically looks and how we will generate it. So depending on that we can now compare both cycloidal and involute profile teeth. The first comparison is pressure angle. You can clearly see, as I already told, pressure angle varies with profile. Okay, in case of involute profile we are not varying the profile. Okay, we are not changing from epicycloid or let's say like in cycloidal we do epicycloid to hypocycloid, like that. uh, Basically change in the profile we are not doing, the same profile is continuing. So pressure angle is constant throughout the engagement of the tooth in case of involute profile, whereas in case of cycloidal profile the pressure angle varies from maximum at the beginning of the engagement, then it will reduce to zero, and then reduce to zero at the pitch point, and then again increases to the maximum value at the end of the engagement. So in cycloidal teeth profile there is a variation in the pressure angle, okay, from the beginning of the engagement till the end of the engagement, whereas in case of involute profile teeth, um, throughout the engagement of the teeth pressure angle is same. So what is outcome of it? Outcome of it is will have smooth running of the gears. Okay, there is smooth running of the gears, and in case of cycloidal teeth will have less smooth running of the gears. Okay, so this is one point. Another point, as I already discussed, or as I already explained to you, in case of cycloidal teeth profile, double curve is used. Okay, epicycloid and hypocycloid. So it complicates the manufacturing of this profile. Whereas in case of involute teeth, we just use a single curve, which results in a simplicity in manufacturing. Okay, so one is difficult to manufacture, that is cycloidal profile. Easy to manufacture, that is involute profile. If it is difficult to manufacture means what? It is more costlier. If it is easy to manufacture means it is comparatively cheaper. Okay. Yeah. If you look into the cycloidal teeth, you can clearly see there is a convex and concave curve. Because of that, so as to avoid more rubbing and wear, the exact center distance is required to transmit the constant velocity ratio in case of cycloidal teeth. Okay, whereas in involute profile, little variation will not affect the velocity ratio. Okay, so basically let's say if required, let's say center distance is CD, and so that should be accurate. whenever it comes to cycloidal teeth profiles, gears which are in mesh with each other, and you can have a little bit tolerance on top of it when it comes to a involute teeth profile. In cycloidal tooth profile, you can see there is like this concave shape at the bottom. Okay, this one. Because of this, what will happen? The other gear which is meshing with this gear, there is no chance of undercutting in the sense removing the material or rubbing at the edge, okay, or at the end we can say. Whereas in case of involute profile, the curve looks something like this. So there is a chance that the gear which is in mesh with this first gear can cause interference. What is interference? Interference is basically, let's say one gear is touching or basically start crossing the limit of let's say, or start touching the base circle of other gear which is in mesh. Okay, so what will happen because of it? It is interfering with the base circle, and it may reduce, or it may remove the material. Okay, so this phenomenon will occur in case of involute teeth profile, but will not occur in cycloidal tooth profile. Okay, this is main advantage of cycloidal teeth, because we have already undercuts are like that we are given here. Okay, and where in case of involute profile, so as to avoid that, we can give either undercuts here, okay, or what we have to do is we have to satisfy the condition of minimum number of tooth on gear in order to avoid this interference. Okay, so that I'll explain in the upcoming slide. What is the formula, or what is the criteria for the minimum number of tooth, minimum number of teeth on the gear in order to avoid the interference. But as of now, you should know that why interference is occurring. Okay, because of their profile difference at the bottom. Okay, so here we already have an undercuts. Okay, because the curve is like a concave, so there is no chance of interference of meshing gear with it. Okay, so if any other gear teeth is coming, it is not it will not interfere with the this present or the first gear, and basically we can easily avoid the interference. But in case of involute profile, that is not the case. We don't have such kind of undercut or concave part present in this profile. We only have convex part. Okay, and because of that, interference can occur here, but by deciding the optimum number of teeth so as to avoid the interference will help us in case of involute teeth. So as I said, the teeth have spreading flanks. So yeah, this is the meaning. This concave part is nothing but spreading flank. So we already said this is a face and this is flank, right? So the flank part is spreading inside the gear. Because of that, what will happen? They are a bit stronger compared to that of involute. Whereas in case of involute profile, the teeth are not spreading. Okay, basically a radial flank, you can say. So they are if we compare them with the cycloidal teeth, they are not much stronger. Okay, so weaker as compared to cycloidal form. Okay, as I already said, there is a concave and convex part, so causing a less wear in this case. Interference is less in case of cycloidal teeth, and here the two profiles which are, let's say, in contact are basically convex, so there is a more chance of wear. Okay, so what are the good points here about the cycloidal teeth profile? It is stronger because of the spreading flanks. Phenomena of interference will not occur. okay, because we already have the concave part at the flank, okay, which can help us to avoid the interference. And also we have less wear in this case. What are the good things about the involute teeth profile? We can have a constant pressure angle, and which results in a smooth running of the gears, okay. And in this case we are using only one profile for the manufacturing, so it is easy for manufacturing, and hence the uh, it is comparatively cheaper than that of cycloidal profile, okay. And a little variation in the you can say the center distance is allowed in case of involute teeth profile. So these are the different, or you can say, pros and cons whenever it comes to a cycloidal profile or a involute profile, okay. So you can expect some theoretical questions from this, either match A or B or choose the correct option. So if you know these details, you will be easily able to answer those questions. Okay, can I proceed towards next slide? Okay. So there is one part or a couple of parts we have to study now. Some relationships, basically. What is velocity of sliding? Okay. Whenever we started studying the lob gearing, I explained you, I shown you the same figure, and I told you that along the common normal, there should not be a separation or the penetration, correct? So as to have a, let's say, a constant angular velocity, if you remember this point. Body A and B, or body 1 and 2 here, they are, let's say, enmeshed with each other and rotating at a constant angular velocity. In order to achieve that constant velocity, there should not be a separation or penetration along the common normal. Okay, this is what we have studied till now. So what does it mean? Okay, it means that the curved surface of two teeths, that is gear 1 and 2, are should remain in contact, okay, and one can slide relative to the motion of the other. So for example, if first gear is the driving gear, the second gear will be in contact with that, okay, and it will move relative to the motion of the first gear. So basically one will slide with respect to other, we can say, along the common tangent, okay, because the uh, in this direction it has to slide. So what is the component of VC along the tangent? Component of VC along the tangent, that is VC sine of alpha, correct? Similarly, component of VD along common tangent is VD sine of beta, okay. And what is the relative velocity of sliding? Relative velocity of the sliding is, let's say, VC sine of alpha minus VD sine of beta. This is the relative velocity. Sorry, this is relative velocity of sliding. Okay, I'll repeat. So according to lob gearing, we said that the gear 1 and 2 should remain in a contact with each other. There should not be a separation or penetration along the common normal, and we want them to have constant velocity, okay. That is achieved by making sure that 1 and 2 gear is is in contact with each other, and the one gear will have a sliding motion relative to the other gear along that common tangent. So that is why we are calculating the relative velocity of sliding. Relative velocity of sliding is Vc sine of alpha minus Vd sine of beta, because the velocity of first gear is, let's say, Vc sine of alpha along the common tangent. Velocity of second gear will be Vd of beta along the common tangent, and difference between them will be the relative velocity, okay, of sliding. Now you can further simplify this if you want. Vc, let's keep it as it is. Vc, what Vc means? Omega 1 into AC, right? And what is sine of alpha? Sine of alpha is perpendicular divided by base, sorry, perpendicular divided by hypotenuse, that is DE, or sorry, EC divided by AC, okay, minus Vd means omega 2 into BD. And what is sine of beta? Sine of beta is perpendicular divided by hypotenuse, that is FD divided by BD. Okay, BD will get cancelled, AC will get cancelled. So ultimately, omega 1 into EC plus minus omega 2 into FD. So E to C part can be written as EP plus PC. Omega 1 times EP plus PC minus omega 2 times FD can be written as FP minus PC. Okay, you can write it like this. So FP minus PD basically. Yeah, PD. Let's call it that point as D. Now, if you further simplify it, omega 1 EP plus omega 1 PC minus omega 2 FP plus omega 2 PD or PC, because D and C point is same, so I can write this PD as PC also. Okay, so what we can do, let's say PC is common here, you can take it together, omega 1 plus omega 2 times PC, okay, and omega 1 EP minus omega 2 FP. Okay, what is that? That is law of gearing we have studied. If you remember, what was law of gearing? Omega 1 divided by omega 2 is equal to omega 1 divided by omega 2 is equal to BP divided by EP, and that is equal to FP divided by EP. Correct. So ultimately, what I can say that omega 1 times EP is equal to omega 2 times FP. Can we write it like this? Yes, right. So omega 1 times EP is equal to omega 2 times FP. Both are same, so they'll cancel out with each other, and we'll end up with this value, that is omega 1 plus omega 2 times PC. So what we can say is velocity of sliding is equal to sum of angular velocities of two gears, that is omega 1 into omega 2, okay, multiply by the distance between the pitch point. What is PC? PC is the distance between pitch point and the point of contact. Okay, PC is nothing but the distance between pitch point and the point of contact. Okay, so this is one thing you should know. Some of the other topics which we already studied, but I have not given you the formula for it, that I'll give you now. Like path of contact, arc of contact, number of pairs in contact, etc. So that we'll study in upcoming slide. Can I proceed to the next slide? So if you remember, we have already studied this definition. What was the path of contact? Can you tell me in this figure what is, how will you, what is the name for the path of contact? CD, correct. CD is the path of contact. So path of contact is basically CP plus PD. Okay, CP plus PD, that is let's say path of approach plus path of recess. Okay. Yeah. So I'll not go into the derivation part here. Like how exactly the formula is calculated, you can go through it through the reference book if you are interested. But it is just by, you are just calculating these distances. Okay, you already know the angle of action. You know the angle of let's say um, approach and angle of recess. That is alpha is the angle of approach and beta is the angle of recess. The overall whole angle is delta in this case, and the phi is a pressure angle. Okay, so um, so basically using this phi itself, we have a relationship, and that I'll give. So the path of contact is calculated by formula, this formula, the root of Ra square minus R square cos square phi plus under root of Ra square minus R square cos square phi minus R plus R times sine of phi. What is this Ra? What is this small ra? What is this capital R and small r? Small r is for the pinion. Okay, the small letters are for pinion. Okay, this is R. Correct it here. This is small r here. Okay, the small letters are for pinion and capital letters are for wheel or gear, you can say. So what is A? And A stands for addendum. Okay, and if you don't write anything in combination with R, that's corresponding to the pitch circle. Okay, so what is RA? RA is addendum circle radius of capital R stands for capital R stands for wheel. So RA is addendum circle radius of gear. So small RA will be the addendum circle radius of pinion. Okay, what is capital R? It's a what is capital R? Capital R is a pitch circle radius of pinion. Sorry, pitch circle radius of wheel or gear, because it's a capital, and small will be pitch circle radius of pinion. Okay. So using this relationship, we will be able to find out the total path of contact. Path of contact is a linear distance from the basically beginning of the engagement till the end of the engagement. Can you tell me what is arc of contact in this figure? With just names, EPF and APB. Correct. EPF, you can say, or AP B also you can say. So now the relationship between arc of contact and path of contact is that. So I'll go to the next slide. Arc of contact is equal to path of contact divided by cos of phi. So basically a distance CD divided by cos of phi, you can say it as a arc contact. And what is contact ratio? Contact ratio is number of pairs of teeth in contact. Okay, pair in the sense we are talking about gear and pinion. How many number of teeth, pair of teeth are in contact? We can call it as contact ratio, and that is given by arc of contact divided by circular pitch. Okay, and what is arc of contact? CD divided by cos of phi. And what is circular pitch? 1 upon p, let's say. Okay, 1 upon small p, right? You have studied in the last class. That is pi d by t. So if contact ratio is expected in the exam, you have to you need arc of contact for it, and in order to calculate arc of contact, you need path of contact for it. Okay, in order to calculate the path of contact, you should know the radius of the addendum and the pitch circle for both gears and the pinion, and including the pressure angle phi. Okay, so these are the formulas you should know. This point I have already explained you the interference and undercutting. What is interference? As I said, like when two gears are in mesh with each other, it is possible that the involute portion of the one will contact non-involute portion of the other gear. Okay, so non-involute portion in the sense this portion in between is a non-involute portion, right? So the first gear will start interfering or will come in contact with this non-involute portion of the other gear, and basically it can cause a wear and material removal from the first gear. Okay, and okay, so or let's say somewhere here it will cut the material. So in order to avoid that, what we can do, we can do some kind of undercutting. Okay, yeah, so basically if you do some undercutting, obviously let's say the strength of the gear will reduce a bit because you are reducing this area at the bottom part of the gears. Okay, the phenomenon of cutting the root of the gear deeper than the involute tooth profile. Okay, okay, the phenomenon of the tooth of the gear deeper than the involute tooth curve when undercutting is large. Okay, so whenever you are making large undercutting, what is happening is the root of the gear becomes narrower, and the tooth will become weak because of the bending strength, because strength of the bending strength in the bending will start reducing if you make a larger undercuts. Okay, in order to avoid this interference. So this is how our, let's say, involute profile looks. Okay, and if you are removing the material of the root of the gear deeper than this involute tooth, so maybe let's say something like this. Okay, so you are making some undercutting here that will cause that we can use in order to avoid the interference, but ultimately because of it the root will become little bit narrower. Okay, if you are doing it from both the sides, it will become narrower, and it will cause it will make the teeth or tooth weak in its bending strength.
Sir,
Yeah,
will the both the face and flank are involute, sir, or only the face will be involute in case of involute tooth?
in involute profile, both face and flank are involute like this. Okay, I'll just show you here. Go back and show you here. This is how it will look. Both including face and flank, both all are involute. Okay, So look at this. So a single curve is used in case of involute profile, both face and flank.
In cycloidal, only there was no interference, no, sir.
In cycloidal, the upper part, that is face part, is made by using epicycloid, whereas the flank part is made by using hypocycloid. And in this
Okay.
case, already undercut is there, because of it, let's say interference phenomenon, and the wear, let's say, is not there in case of cycloidal.
Okay. Thank
Yeah. Okay. Can I move towards next slide? So this formulation is very, very important from exam point of view. You should know this formula. Okay. So as I already mentioned, that in case of uh, cycloidal tooth profile, there is no chance of or there is no interference, whereas in case of involute profile there is an interference, but you can avoid the interference by deciding the number of teeth or minimum number of teeth in order to avoid the interference. So the number of teeth in the involute profile should always be greater than or equal to 2 times a omega or aw divided by under root of 1 plus 1 upon g times 1 upon g plus 2 sinus square phi minus 1. Okay, a little bit difficult formula, but we'll make it simpler. Okay, what is this t? This is number of teeth, okay, on a wheel which we want in order to avoid the interference. What is this aw? Aw is nothing but the addendum coefficient. What is addendum coefficient? Generally it's 1, right? One module. I explained you
you.
whenever. Yes.
Will -1 will be outside the square root or in the square root, sir?
Everything
In
is
denominator.
yeah, everything is in square root. Yeah. Okay. AW is the addendum coefficient. Addendum, I explained you, it's like is equal to one module, and addendum is 1.15 something times module, if you remember in the last class I explained. So basically addendum coefficient is generally 1, but in some cases it can be more than 1. Okay, so let's say it is 1.15 times module or something, so that whatever number you are multiplying with the module is your coefficient. Okay, and generally the value of the addendum coefficient is 1. So how this formula will change? So t should be equal, I'm using the limiting case, that's why just writing equal to, because we are talking about the minimum number of teeth. So it's a 2 times under root of 1 plus 1 upon g into 1 upon g plus 2 into sinus square phi minus 1. Okay, what is this g? G is nothing but the gear ratio. Okay, g is nothing but the gear ratio. Suppose you have a gear ratio of 1. The meaning of gear ratio of 1 is you have the same size of the gear basically. Okay, ratio of number of teeth and gear to that of pinion is called as the gear ratio. If it is 1, it means the size of both the gears is same, you have same number of teeth, okay, on both pinion and gear. So ultimately why you are doing, just using that gear trains just to transmit the motion for from one shaft to the other with the same velocity. Okay, so gear ratio is 1 basically. So how this formula will look like? A simplified version of it. Okay, for this particular case we are saying, okay, for this case, under root of 1 plus 1 upon g will be 1, 1 upon g again 1, plus 2 will become 3, so this will become 3 sinus square phi minus 1. Okay, so here what we can see is the or the relationship is getting simpler. +1 -1 will get cancelled out here, and you will have ultimately 2 divided by 3 sin square phi. Okay, 2 divided by 3 sin square phi. Okay, and what is this phi here? It's a pressure angle. As I said, generally we are using 20° or 30° pressure angle. So let's say 20° pressure angle will give you the value of 2 divided by under root of 3 sin square 20, and if you calculate it, you will get around 12.31. 12.31 is not a number, so basically 13 is a round of number. More than 12 gears, but less than 13, it means more than 12 gears means the next number is 13. So you can say that at least 13 number of gears are required, or 13 number of teeth are required on a gear if you have a pressure angle of 20° and a gear ratio of 1, in order to avoid the interference in case of involute teeth profile. Okay, are you getting it?
Sir, it was outside the root, sir. Then only we get it. -1 was outside the root, sir.
Okay, let me just check the formula once again.
If it was not there, we getting 3.
Okay,
2 by root.
okay, let me just check a formula. Yes, correct. Thanks for correcting it. It is outside the root. Okay, yeah, so it will not cancel out then. Okay, so it is under root of 1 plus 3 sin square phi minus 1, and if you put this 20°, what you will get is 2 divided by under root of 1 plus 3 sin square 20° minus 1. Okay, so this is different part, and 1 is the outside the bracket. Okay, so what I can conclude from this is 2 wheels of equal size with a 20° pressure angle, and if addendum is equal to the 1 module, okay, then the minimum number of teeth on each wheel should be 13 in order to avoid the interference. Okay, yeah, I think now it's correct. This one is the outside this root. Yeah. Okay. Can I move towards next slide? Yeah, I think um, that's all you need understanding from the gears part. Okay, and now I'll introduce you the gear train part. I will try to introduce, we'll bring the gear train part in combination with it in order to link these two topics. Okay, till now whatever we have studied is only for one particular gear, or let's say a gear which are in pair, but it's not necessary that we just have two gears, one is pinion and another one is wheel. We can have, let's say, uh, a train. Okay, let's say a 4 or 5 gears, let's say connected from one to other. Either they can be mounted on the same shaft or different shafts. So in order to avoid this in order to understand this kind of situations, um, we have to study the gear train topic. Okay, so I'll just open the different presentation. Okay, write down heading gear trains. What is gear train? As I said, it's a combination of gears used to transmit the motion from one shaft to another. Okay, um, so whenever you want to reduce, let's say, speed from one shaft to the other shaft in a very small space, um, you need a gear train. Okay, and you have to arrange them in a such a way that, let's say, you will achieve whatever required speed you want. The gear trains are of four types: simple gear train, compound gear train, reverted gear train, and planetary. You can call it as epicyclic gear train also. Okay, I'll just list them here. Simple, compound, then reverted, and the next one is planetary. And you can call it as epicyclic also. When we call it as a simple gear train, in simple gear train, on each shaft we have one gear. On each shaft you have only one gear. So you can clearly see first, second, third, fourth, and 5 gears in this particular diagram. You can clearly see on each shaft there is one gear. So I'll say that each shaft supports one gear in case of simple gear train. Each shaft supports one gear. Correct. In case of compound gear, we will look into the upcoming slides, but we can say more than one gears are mounted on a shafts, except the first and last gear. Okay, except the first and last gear. Let's say a shaft supports, let's say, 2 wheels or something like that, then you call it as a compound gear train. Okay, in simple we have only one gear on each shaft. In compound we have more than one gear on a shaft, except first and last gear. What is first gear? Let's say in this case first gear is 1 and last gear is gear number 5. Okay, so in compound gear train there is a possibility that in shaft 2, 3, or 4 you can have more than one gear. In reverted gear train, it is more or less similar to the compound gear train, but the axis of the driving gear and the driven gear is same. Okay, so here this axis is here, this axis for the first and fifth gear, they are different, right? They are far apart from each other. But if the axis of the first gear and the axis of the second last gear, okay, the first gear and the last gear is coinciding with each other, we call it as a reverted gear train. Okay, it is also a type of, you can say, compound gear train. And the last one is a planetary gear. So in this all these cases, what we can see is shafts are fixed. Shafts are fixed. Okay, so this shaft is not moving. This particular shaft, this particular shaft, this particular shaft, they are fixed. Okay, in this case, in all these three cases, that is a simple gear train or a compound gear train or a reverted gear train, in all these three types, the axis of rotation of the wheel is fixed in the position and the gears are rotating with respect to the axis. But in some cases it is possible that axis is also let's say not fixed, it is also rotating around some axis of the other wheel. In those cases, that kind of gear train is called as a planetary gear train, and we'll see it in detail in upcoming slides. Okay, so as of now what we can understand here is in this together is like a one type, and this is another type, where depending on the whether the shaft axis or shaft is fixed or not. Okay, shaft axis is fixed or not. Okay, so let's start with a simple gear train. Okay, as I said, each shaft supports one gear. Whenever you attach series of such gears, okay, transmitting the motion from one gear to the as a simple gear train. Okay, so let's say first gear is rotating counterclockwise direction, then adjacent gear 2 will rotate in clockwise direction, then the third gear will rotate in counterclockwise, fourth will rotate in clockwise, fifth will rotate in counterclockwise. What we can understand from here is the odd number gears, that is 1, 3 and 5, will rotate in the same direction, that is counterclockwise in this case. Okay, and the even number gears rotate in the opposite direction, that of the odd number gears. Okay, the gears which are in odd number will rotate in a opposite direction, that of even numbered gears in case of simple gear train. Okay, is it clear till this? Main thing you should know here is your shaft axis is fixed, you're not changing it, and you have one gear on each shaft, and the first gear is a driving gear, the last gear is a driven gear, um, and in between you have this connecting gear just to transmit the motion from one shaft to the other shaft, and um, the even number gears have the rotation in opposite direction, that of odd number gears. Now the speed ratio thing comes into the picture here. Okay, in gear train we use the term called as speed ratio and the train value. As we are talking about the train here, gear trains, okay, that's why this train value is coming into the picture. um, Train value is inverse of that of speed ratio. Okay, and what is speed ratio? Speed ratio is the ratio of driving gear to that of driven gear. Okay, ratio of speed of driving gear to that of driven gear. Okay. Whenever you are in gear train, don't use pinion and gear terms. Okay, because here all are here we are not talking about two gears. Like whenever we have two gears, we use pinion and gear terminology, because one will be smaller, other will be larger. But in this gear trains we have more number of gears. Okay, so using that terminology will not be helpful. So let's speak it as driving gear, driven gear, in those manner. Okay, speed ratio is the speed of driving gear to that of driven gear. Okay, driven gear speed, and train value is um, opposite to that of speed ratio. Okay, uh, so let's try to calculate these train values and speed ratio for this simple gear train. Okay, so if you just focus up on these first two gears, that is first and second gear, can I write n2 by n1 is equal to t1 by t2? We can write it, right? um, because speed is inversely proportional to the number of tests, and also inversely proportional to the diameter. I can write it as a d1 by d2 also, and I can write it as omega 2 by omega 1 also, right? So we have already studied, so let's focus on only this speed and number of teeth part. N2 by n1 we can write it as a t1 by t2. If I talk about the second and third gear, can I write n3 by n2 is equal to T2 by T3. Yes, we can write, correct? Whenever we talk about this pair, 2 and 3. Whenever we talk about 3 and 4 pair, N4 by N3 is equal to T3 by T4. And whenever we talk about the last pair, 4 and 5, N5 by N4 is equal to T4 by T5. Okay. So ultimately, if you multiply left hand side and right hand side, how the stuff will look like, I'll show in the next slide. First was N2 by N1 is equal to T1 by T2, correct? Second was N3 by N2 is equal to T2 by T3. Third one was N4 by N3 is equal to T3 by T4. Okay, and the last one was N5 by N4 is equal to T4 by T5. Why? Because this is equal to this part, this is equal to this part, this is equal to this part, and this is equal to this part. Okay, so if they are equal, then their multiplication is also equal. I hope you understood. Okay, so now you can clearly see N2 N2 can get cancelled, N3 N3 will get cancelled, N4 N4 will get cancelled. So in left hand side we have N5 by N1. Similarly in the right hand side, T2 T2 will get cancelled, T3 T3 will get cancelled, T4 T4 will get cancelled, and you will have T1 by T5. So train value is equal to or speed, yeah, train value is what? N5 by N1. Okay, and speed ratio is N1 by N5. What is speed ratio? Is number of speed of the driving gear to that of driven gear, N1 by N5. You can write it as T5 by T1. And the train value in this case is T5 by T1. Sorry, T1 by T5. Okay. So what we can conclude out of it is the speed ratio and the train value is depending on only first and last gear. Is depending on only the first gear, that is driving gear, and the last gear, which is driven gear. Okay, the intermediate gears don't have any role in deciding the value of the speed ratio and train value, because the terms will get cancelled out. Whatever is the value of, let's say, N2, N3, N4, whatever is the value of T2, T3 and T4, it's ultimately getting cancelled in this expression, and the train value and the speed ratio is just depend on the first and last gear, and intermediate gears don't have any effect on the speed ratio and the train value. Okay, this is something different in the simple gear train that of compound. In compound gear train, this is not the case. Okay, because we are not just mounting one gear on each shaft. So let's say here we do have the series of shafts connected via gears. Okay, but on one shaft there is more than one gear. Okay, look at the figure. First gear is connected to the second gear, and second gear is on this, and the third gear are on the same shaft. Okay, now let's say the first gear is rotating in counterclockwise direction, second gear will rotate in a clockwise direction. If second gear is rotating in clockwise, third will also rotate in clockwise, because they are mounted on the same shaft. Second and third gear mounted on same shaft. Okay, so they will have same direction. Okay, so they'll rotate in the same direction. Okay, in this case they are rotating in clockwise direction. So now the next gear 4 is connected to gear number 3. Okay. Gear number 3 we are connecting to it, and the gear 4 and 5 are mounted on the same shaft. 4 and 5 mounted on same shaft, and ultimately they will rotate in same direction. Okay, and then gear 5 is connected to the gear 6. Gear 5 is also connected to a gear 6. Are you following how? So here we cannot say that odd number gears and even number gears are, let's say, in the same direction, or those kind of conclusions we cannot make here, because we don't know how many gears are there in the each shaft. Okay, or because in case of intermediate gears, in case of intermediate shafts, we can have more than one gear. Okay, so this kind of, but except first and last gear, on the first and last gear you should have let's say a single gear. So the same formulation I can do here. N2 by N1, what I can write? N2 by N1 is T1 by T2. If I talk about the first and second gear is not connected to the third gear, right? They are on the same shaft, they are not in touch with each other. But gear whatever is the speed of N2, the same speed is of the rough. N2 and N3 is same, we can say, basically, correct? Because they are mounted on the same shaft, so their rotating speed is same direction, same shaft, same speed. Okay, now but 3 and 4 is in combination with each other or connected to each other, so N4 by N3 you can write, which is T3 by T4. 4 and 5 are mounted on the same shaft, so they have same speed, and 4 is not connected further, so you have to connect. As you can see, 5 and 6 are connected, so N5 by N6 by N5 is equal to T5 by T6. N5 by N6 is equal to T5 by T6. Okay. So now, if you do the multiplication again, as I have explained in the simple gear train, N2 by N1 into N4 by N3 into N6 by N5, you can write it as T1 by T2 into T3 by T4 into T5 by T6. Okay. N2 by N1. You already know that N3 can be written as N2. Do you agree? And N5 can be written as N4. So I can rewrite this expression as N2 by N1 is equal to N4 by N2, into N4 by N2 into N6 by N4, that is equal to T1 by T2 into T3 by T4 to T5 by T6. See, the shaft, the gear 2 and 3 are mounted on the same shaft. They have same velocity. That doesn't mean they have same number of teeth, because the size can be different and the number of teeth can be different. Okay, so that's why I'm not doing this thing I'm not touching the number of teeth part, only the speed part I am touching, because if the gears are mounted on the same shaft, they will have same RPM. Okay, so N2 N2 will get cancelled, N4 N4 will get cancelled, N6 by N1 is equal to T1 into T3 into T5 divided by T2 into T4 into T6. Okay, product of number of teeth on driving gear. So here you can clearly see the first gear is a driving gear. The gear number 1, 3 and 5 is a driving gear. Gear number 2, 4 and 6 are driven gear. Okay, so the N6 by N4 is a train value. Train value is equal to N6 by N1. Gear ratio, sorry, not gear ratio, speed ratio is equal to N1 by N6. So train value, you can say it has N6 by N1, which is equal to product of number of teeths on driving gear, product of number of teeth on driving gear to the product of number of teeth on driven gear. Okay, so this is what you can conclude out of it. So here you cannot say that intermediate gears have any role, don't have any role. They do have some role. Okay, in deciding the train value and the speed ratio, they do have role. Okay, because number of teeths on first gear and last gear is also important, but also number of teeths on all intermediate gears is also important, because you can clearly see T2, T3, T4, T5 is part of the train value and the gear ratio. Okay, can I proceed to the next slide? Yeah. Okay. The third type of gear train is a reverted gear train. The third type of gear train is reverted gear train. Wait, just give me a minute. I'll drink water and then we'll continue. Okay, I'll just give a 1 minute break. Okay, coming back to the third type, that is inverted gear train. Yeah, it is more or less similar to that of let's say the compound gear train, because there is chance there is like more than one gears mounted on the same shaft. But first and last gear uh, of the compound gear train, if it is coinciding with each other, then we call it as a inverted gear train. Okay, so what I can say that if the axis of the first gear, first and last wheel, okay, coincides last wheel of a compound gear train, coincides, then it's called as inverted gear train. Okay, so look at the figure here. The first gear is in connection with the second gear. So first gear, if it rotates in clockwise direction, second gear will rotate in counterclockwise direction. The gear number 2 and 3 are mounted on the same shaft, so they will have same rotation RPM and they will have same direction of rotation. Okay, so the gear 3 will rotate in counterclockwise direction, as gear 3 is rotating in counterclockwise direction, and that is in mesh with the gear 4, so gear 4 will rotate in the clockwise direction. Okay, and the gear 1 and gear 4 are along the same line, so their axis is coinciding. Okay, so this is the axis of the first gear, this is the axis of the fourth gear, it is coinciding with each other. So the definition is correct that if the axis of the first and the last wheel of a compound gear train coincides, then that particular train you call it as a reverted gear train. So whatever we have studied for the compound gear train is still applicable for this. So you don't have to derive again. So directly I can say that N4 by N1, that is the train value. Okay, is equal to product of number of teeth on driving gear. So yeah, driving gear to the product of number of teeth on driven gear. Okay, so product of number of teeth on driving gear is what? Here the driving gear. Can you tell me which are all the driving gears in this case? Can anyone tell me in this 1, 2, 3, 4 which are all the driving gears? Yeah, 1 and 3. So it's, I can say T1 multiplied by T3 divided by driven gears are T2 and T4. Okay, so this is the train value, and you can also calculate the gear ratio. It is opposite of train value. One more speciality of this particular gear is the center distance between the gears is same. Okay, the size of gear 1, 2, 3 and 4 is different. All gears are of different size, but this, and they also have different number of teeth, but the center distance in between gear 1 and 2 and the center distance in between gear 3 and 4 is same. So CD1 is equal to CD2, that you have to note. And what is center distance in between first and second gear is the radius of the first gear plus radius of the second gear is equal to radius of the third gear into radius, sorry, plus the radius of the second gear, sorry, third and fourth. Can you further write it in terms of diameter? Diameter of the first gear plus diameter of the second gear equal to diameter of the third gear plus diameter of the fourth gear. Can you write it like this? And then you can basically module is equal to d by t. If the gear 1 and 2 should have same module. Okay, so I can I write it like, let's say module of first and second gear is m1 let's call it as ma, and the module of the third and fourth gear has to same, let's call it as mb. Then can I write this expression as let's say ma t1 plus ma t2 has to be equal to mb t3 plus mb t4. Or let's say if you take ma common, it's t1 plus t2 equal to mb common t3 plus t4. Can you write it like this? Is it clear? And if module of first, second, third and fourth gear is same, that means ma is equal to mb. You can also cancel out with them, and ultimately you can say sum of the teeth on first and second gear is equal to sum of the teeth on third and fourth gear. If that is a special case, that is ma equal to mb. Okay, I hope you understood till this. If you have any doubt, feel free to ask. So this is just very easy chapter or easy topic. You should know the speciality of each gear train. Okay, the speciality of reverted gear train is the axis of the first and the last gear is same, and center distance is same. Center distance same is means sum of the radius of first and second equal to third and fourth. it means diameter of the first and second equal to the third and fourth. So you can, all these things you can make out of it if you just know the basics. Okay, or and you can solve any problem on the inverted gear train, or let's say no, it's not inverted, let's call it as a reverted. Okay, a reverted gear. So in lathe machine, this gear train is used. Is it clear till this? Yeah. Last type of the gear train is planetary gear train. So what we have studied is simple, compound, and reverted. As I already mentioned, in all these three cases, your axis of the shaft, all shaft axes are fixed. The shaft axis is not moving. But if shaft axis is moving, then in that kind of gear train you can call, or if that is moving around a shaft axis of the another gear, then you can call it as a planetary gear. The name planetary gear is given because you can clearly see, you know that like if we have a sun and earth revolves around the sun, so the axis of the rotation, so okay, so this is sun and this earth is rotating about itself, okay, um, and it is also rotating about the sun. So here is the actual rotation of the earth, and this axis of the rotation is changing, okay, here as it rotates around the sun, okay, or let's call it as a planet in general. So planetary gear train, you can say it as a gear train in which your axis of a gear is not fixed. Shaft axis is rotating around axis of another gear, okay, then we call it as a planetary gear. So this is the main difference you should know in between all these three gear trains which we have studied and the planetary gear train, okay. So as I said, it's not just a planetary gear train, you can call it as a epicyclic gear train also, okay. So you can, in this case, the gear around which the another gear is rotating is called as sun gear, okay. So you can write it, denote it by S. So yes, it is more commonly used name, so you should know this. S stands for sun, P stands for planet, so this is a planet gear. The planet gear is rotating about the sun, and how we are making sure that it is not going away from the sun by using this arm A, okay. So the sun gear and the planet gear is connected through this arm, okay, which is passing through the axis of both the gears, okay. And if you rotate the arm, basically planet gear starts rotating about itself and also rotating about the sun gear. I hope you are able to follow um, how it is. So it is not only just rotating about itself, it is also rotating about the sun gear, okay. If you just rotate the, if you just give some motion to the arm. Is it clear till this? So what will happen if I fixed arm A? Okay, so here what I said, we have three things. One is arm, we have a planet, and we have sun. Okay, I'll remove this. I expect you know it now. Suppose this arm is fixed. What will happen? What will happen if this arm is fixed? Yeah, it will become a simple gear train. Okay, why? Because this axis is fixed, this axis is fixed, and then there is nothing different than simple gear train. Okay, we have one gear and one driving gear and one driven gear. So if RM is fixed, epicyclic gear train or planetary gear train will be converted into a simple gear train. Okay, so this is one situation. Another situation is, let's say if you fix the sun, what will happen? Okay, however, if you fix the sun gear, what will happen? And if you rotate the arm, as I explained before, your planet gear will not just rotate about itself but also rotate around the sun. Okay, and that's why the term planetary gear train is used here. Okay, and what is you remember epicycloid? I have explained you the term cycloid. Cycloid is a curve traced by a point on a circumference of the circle. Okay, when it moves on the when it rolls without sliding on a surface, on a flat surface basically. But cycloid can be either epicycloid or can be hypocycloid. So epicyclic gear train means if if you are tracing a curve by rotating a point which is lying on a circumference of the wheel on a circular disc. Okay, so then the curve traced by this point is called as a epicycloid. That's why you can clearly see here. If you trace any point here, it will create a epicycloid. Okay, and that's why the term epicyclic gear train is also can be used to understand this gear train. Okay, planetary because it's like a similar to sun planet. Okay, and epicyclic because it is creating a epicycloid. Okay, so this is one possible case. Another possible case can be, let's say this fixed gear is outside and you are, let's say, this is also a possible case. Okay, we have three gears. So let's say this is a fixed gear and this arm and this is sun and planet. So in this case, if you trace a curve on this point, it will create a hypocycloid. Okay, so it will also create a hypocycloidal curve. That's not uh, uh, thing like if even if it is called as epicycloid gear train, there is possibility that if you just have a, let's say, a fixed gear like this, okay, which is outside this gear train, fine, then what will happen is or let's say it is moving also depending on what kind of motion you want. Okay, so basically in this case also you can generate a or let's say it is fixed, and if you are moving it, then in that case you will generate a hypocycloid. Okay, so this kind of gear train is also possible. You can just have one gear, or let's say you can have one more gear here, you can have one more gear here, and all you can just connect through a arm, a common arm also. Okay, this kind of gear train is also possible. So ultimately it's nothing but the same thing. It is a epicyclic gear train, or you can call it as a planet gear train. So we have three planet gears and one sun gear. And outside gear you can call it as anything, let's say capital S or some R gear. You can give some other names to it. Okay. I hope it's clear till this. Yeah. The main question comes now is how to analyze it. Okay, so it was pretty simple in the previous cases, like simple gear train, compound gear train, on reverted gear trains. But in this case, the analysis of epicyclic gear train is a little bit complicated. It's not that easy. Okay. But whatever we have studied till now is really helpful in the analysis of it. Okay, so I'll just give some simple example. Let me copy the same figure to the next slide. There are two ways through which you can analyze the epicyclic gear train. One is this a tabular method, and another one is a relative velocity method. Okay, so we'll study both because understanding both the methods will give some details about this gear train. Okay, so I'll just take a simple question to make you feel comfortable about the overall process of analyzing. Okay, so let's take a simple question. An epicyclic gear train we have consists of an arm and two gears. Let's call them and those gears are gear number A and gear number B. Okay, we have gear A and gear B having 30 number of teeth and 40 number of teeth respectively. The arm is rotating about the gear A. Okay, the arm rotates about the center of the gear A at, let's say, 80 rpm. Speed of arm is 80 rpm. Okay, about gear A. Okay, this is what given. The arm rotates about the center of gear A at a speed of 80 rpm counterclockwise. Okay, counterclockwise. What they are asking us to find, they're asking us to determine the speed of the gear B. Speed of gear B. Okay, under the situation, first gear A is fixed. Okay, and the second gear A rotates at 240 rpm in clockwise direction. Okay, so these are the special cases. Try to understand the question. We have two gears. In the first case, the gear 1A is fixed. Okay, and arm is rotated in counterclockwise direction about gear A. Okay, at 80 rpm, and you are supposed to find the NB in this case. So this is the first question. Okay, we will just focus on it, and then I'll explain the concept of second question. Okay, so first of all, try to understand the uh, the part A here, that is gear A is fixed, arm you are rotating at 80 rpm in counterclockwise direction, and they are asking us to find the speed of the gear B. Okay, so you can easily find it out by using relative velocity method, but first I'll explain the graphical method to you. Okay, so you have to perform different steps. Okay, in each step you have to do some action. Okay, and in each revolution, let's say NA, you will get revolution of A gear, or revolution of the arm, revolution of the gear A, and revolution of the gear B, because we have just 2 gear and 1 arm, so that's why 3 columns you have to make. If you have 1 more gear, you have to add 1 more column to it. Okay, so A for small a is for the arm, capital A is for the gear A, and capital B is for the gear B. I hope it's clear till this. Now let's start do the first step. Arm is fixed. So first step always which you have to do is arm is fixed. Okay, if you fix the arm and give 1 rotation to the plus 1 revolution to the, let's say, a gear A, 1 revolution to A. Okay, or plus NA equal to 1 basically. NA equal to 1 means revolution of A gear is 1 and arm is fixed, means its speed is 0. Are you getting it? So what we are doing is arm is we are fixing, means speed of the arm is 0, and we are rotating first gear with 1, so that is becoming as NA is a 1. So what is the value of NB? You know, whenever you are fixing the arm, as you already told me, that it will become a simple gear train if you fix the arm. So if you fix the arm, what will happen? I can write NB by NA equal to TA by TB. Can I write it like this? So what is TA? 30 by 40. So, but NA is 1. So NB is equal to 30 by 40 I can write, because NA is equal to 1. But you can also see that if A gear rotates in a counterclockwise direction, B will rotate in clockwise direction. So whatever is the speed of the first gear, the speed of the B gear will be opposite of it. So I should write it as a minus 30 by 40. Is it clear till this? If you have any doubt, feel free to ask. I'll repeat what I have done. I have fixed the arm. If you fix the arm, the gear train will become a simple gear train, and the NB by NA will become TA by TB. Okay, and that's why minus 30 by 40 I'm writing. Minus term is coming because if first gear rotates in clockwise direction, if A gears rotates in a clockwise direction, B will rotate in counterclockwise direction. Okay, yeah. So the same step arm is fixed, and NA, rather than 1, I am writing X revolutions to it. Okay, if 1 revolution is given, minus 30 by 40 is coming. Okay, minus 3 by 4 in general, to make it more simpler. Correct. And now if I give X revolutions to A, it will become minus 3X by 4. Correct. I hope you agree till this. And now what you are doing, you are adding, you are giving Y revolution to arm. Okay, so add Y. So you are rotating Y, you are rotating arm by Y. So if you are rotating arm by Y, your first gear will rotate by Y, and NB will be rotating with Y. So you have to add Y to all this. So I don't have space here. I'll go to the next slide. So basically sum of this is what? Y. Okay. So N A equal to Y. N capital A is equal to what? X plus Y. Okay. So just focus on these two parts. Forget about the first, because the second part is just the first part is a special case of second part only. So just focus on the variable part. NA is equal to X plus Y, and NB is equal to Y minus 3 by 4 times X. Okay. So what we have done is we have converted the speed of arm, speed of gear A and speed of gear B in terms of some variable x and y. And if we are able to calculate the x and y, we will be able to calculate the speed of arm, speed of gear A and speed of gear B. And how will you calculate the x and y? By just given conditions. Okay, speed. So what we understand from this relation, this relation is that if x is if arm speed is y, okay, then and okay, if arm speed is y, then speed of the first gear is, let's say, x times arm speed. Okay, then at that situation the speed of the gear B will be speed of the arm minus 3/4 of the x. Okay, I hope you understood here. Okay, so let's try to connect it with our question. What was our question? Our question is, if gear A is fixed, okay, if gear A is fixed, arm is rotating in counterclockwise direction at 80 rpm. Okay, so this is our first case. So here, is it correct if I write NA equal to minus 80? So let me look into the question again. Yeah, okay. Let's assume that minus stands for counterclockwise, or it's your choice, whatever you want. Okay, so if you want to assume 80 counterclockwise as positive, you can just assume it as 80, but you should make sure that it is counterclockwise. Okay, but if you get an answer which is negative now, it means that direction is a clockwise direction. Okay, and if you get a positive answer, then that direction is a counterclockwise direction. So that you have to make clear. So your assumption here is, let's say, positive for counterclockwise. So if answer is positive, then direction is counterclockwise. If answer is negative, then direction is clockwise. Make it clear. Okay, so if gear A is fixed, NA is equal to 0. This is given data, right? Do you agree? This is given data. NA is 0. So can I write x plus y equal to 0? Because speed of the gear, so this is equation number 1, 2 and 3. This is, I can write from 2. Correct. So if x plus y equal to 0, NA is equal to 80, means y is equal to 80. So this I can write by using equation number 1. Okay. So from this, x plus 80 equal to 0, and this implies x is equal to minus 80. Okay. So what we are assuming that if you rotate the basically arm by 80 rpm, the gear x, or the it is same as like revolving the gear 1 as at 80 rpm in opposite direction. Okay, no, sorry, gear A is fixed. We are just saying the effective, how much effect you are bringing here by rotating the arm by 80 rpm in counterclockwise. Okay, I'll repeat once again. The arm speed is 80 counterclockwise, gear A is fixed. From that you have calculated the variable x value that will help us to calculate the NB now. So what is NB? NB is equal to y minus 3/4 times x. What is y? Is 80 rpm minus 3/4 times. What is x? Minus 80 rpm. So 4 2s are 0. So it is minus will become plus. 80 plus 60 will become 140. 140 rpm. The answer is positive. Your assumption was positive for counterclockwise, so it means this is also counterclockwise. Are you following it? So what I can conclude out of it is, if your gear A is fixed and arm is rotating at 80 rpm in counterclockwise direction, then the gear B should rotate at 140 rpm in counterclockwise direction. Okay, I hope it's clear to everyone. If you have any doubt in this, feel free to ask. So this is the way you can solve the problem by using the graphic, by using the tabular method. Okay, this tabular method will help us to generate these three equations, and once these three equations are generated, you can solve any problem. Can you tell me the answer for the second question? I'll wait for 2 minutes. In the second question, what we have said is the gear A rotates, revolves at 240 rpm in clockwise direction. Okay, what is NB? What is speed of the gear B? I'll wait for 2 minutes. Solve this. Okay, so for this topic, I have to take question in order to explain you the procedure. But anyway, we will solve this kind of questions again during our problem solving sessions. We'll wait for 2 minutes. You have to solve this question and tell me the answer. Yes, correct. 320 counterclockwise, that is the correct answer. So as we know, let's say a gear A NA is equal to 240 rpm clockwise. So let's assume it as a positive. Clockwise means positive, that is our assumption. We also know that arm rotate in counterclockwise direction, and A is equal to minus 80 because it rotates in counterclockwise direction. This is the given data. Okay, then what we can bring out of it is what is NA? NA is equal to Y, that is equal to yeah, correct. NA is equal to Y, that is equal to minus 80, and capital A is equal to X plus Y, which is 240. So this implies X is equal to 240. Minus 80 will go on that side, it will become plus 80. That is 320. Okay, this is value of X, and the NB will be equal to what? Y minus 3 by 4 times X, 320. So what is Y? Minus 80 minus 3 by 4 times 320. So you will get again a minus number, 80. Okay, minus 80 minus 240, it will be minus 320. So this minus answer, minus 320 rpm. Okay, the minus stands for here now counterclockwise, because your assumption is positive for the clockwise, so it is counterclockwise. I hope it's clear. If you have any doubt, feel free to ask. Okay, can I move towards next slide? Yeah. Another one is the relative velocity method. Yeah. So is it, how can I find the relative velocity of sun with respect to arm? Can I write it as speed of sun gear minus speed of the arm? This is we can say as a relative velocity, you can say, in between sun and arm. Similarly, relative velocity in between planet and arm will be um, Na minus Np. Okay. Um, because sun and planets are in opposite direction that I'm considering here. Okay, so that's why if I take a ratio of it, Nsa by Npa, that is the ratio of the relative velocity of sun with respect to arm and the planet with respect to arm, is Ns minus Na divided by Na minus Np. Okay, uh, the and this ratio is further, let's say Nsa by Npa is equal to Tp by Ts. So because speed is inversely proportional to the number of tits, so Tp by Ts, that is equal to Ns by Ns minus Na divided by Na minus Np. If you want to write Np by Np minus Na, you have to multiply with a negative sign. Okay, so yes, Sean, you can write it, but you have to write the negative sign for it. Okay. Yeah. Or if you don't want, you can write Na minus Np. And generally, whenever they ask you the questions, number of tits they'll give. So this formula will directly help you to solve the question. Okay. So write down this formula. Tp by Ts is equal to minus Ns minus Na divided by Np minus Na. Okay. So let's take a question. Same question. Whatever we have studied before, we will try to solve by using a relative velocity method, and you'll say that it's very simple compared to making table. So you can call this as algebraic method or relative velocity method. What was our first question? Is determine the speed of the gear B if gear A is fixed. Okay. So I can write Ta by Tb in that case. Okay. Equal to minus Nb minus Na divided by Na minus Na. Can I write it like this? And they have given us that speed of the gear A is 0. So Na is 0, they have given. Number of tits on gear A is 30. Number of tits on gear B is 40, equal to, let's say this minus sign you are bringing to left hand side, okay, to avoid confusion. It will be equal to NB, and arm is rotating at 80 RPM in counterclockwise direction. So suppose 80 is positive is clockwise, sorry, positive is counterclockwise. This is your assumption. So that's why minus you kept as it is and written 80 divided by 0 minus 80. Even if you just solve this, you will end up with the correct answer. So this 80 will minus 80 will go in this side, minus minus will get cancelled. 30 into 80 divided by 40 is 60, and NB is equal to 60 plus 80, that is 140 RPM, and that is also positive you are getting. That means it is clockwise, counterclockwise. Okay, counterclockwise since it is positive. And you can clearly see in previous question also, in previous case also, we got the same answer. So you can save a lot of time using this method as well. Okay. In the second case, same thing, minus 30 by 40 I'm writing. We are supposed to calculate NB. Arm is rotating at 80, R in counterclockwise. Here again, counterclockwise is positive, is our assumption. Okay, counterclockwise means positive. NA is rotating, the gear A is rotating at 240 RPM clockwise, so I should write it as a minus 240 minus 80. That's all. So minus 240 minus 80 is minus 320. Minus 30 into minus 320 divided by 40. And then if you add 80 to it, you will end up with the 320 RPM. And you will get a positive answer here. Positive means counterclockwise. Yeah, counterclockwise. Okay, so you can still get the same answer. Okay, so if you remember this formula, it's like the same formula. The speed is inversely proportional to the number of tips. Okay, but it's a relative velocity. We are not just using the NS and NP here, but in combination to that, we are including the speed of the, we are subtracting the arm speed from it. I hope it's clear to you. Any doubt till this? So this is all we have, the theoretical part about the gear and gear train. Things will be clear more or less when we study the when we solve more problems on it during problem solving session at the end. Okay, we got a question from Shruti. In this formula, it is minus NB. Yes, Shruti, what this minus sign I am taking to the left hand side, and I'm writing here. And here also same thing I have written. This minus sign I'm bringing to the left hand side, just to avoid confusion there. Okay, you have doubt about this second? Let's solve it once again. Okay, TA by TB equal to minus NB minus NA divided by NA minus small na. Okay, this minus sign I'm writing on the left hand side. Is it clear till this? Yeah. So number of tips on A is 30, B is 40. NB we have to calculate. So what they have given is 80 RPM. Arm rotates 80 RPM counterclockwise. So here you have to make a decision whether you want counterclockwise as positive or negative. Okay. Suppose counterclockwise is positive, you are assuming. Then I have to just write 80 here. I cannot write minus 80 because this minus sign is as it is, I am keeping. And NA value is 80. Are you following? And if I say counterclockwise is negative, then I have to write it as minus 80. Okay. So if I assume counterclockwise is positive, I have to just keep it as 80 itself. So I'm assuming counterclockwise as positive. The meaning of it is clockwise is negative. And that is the speed of NA. NA is 240 RPM clockwise. I'll go to the first slide. Gear A rotates at the 240 RPM in clockwise direction. So that is the reason I have taken it as a minus 240. Are you following? Minus Na is 80 as it is. So either you can write in this way, or let's say if you are assuming clockwise is positive and counterclockwise is negative, then minus 30 by 40 has to be equal to NB minus of minus 80 divided by 240 times minus of minus 80. Okay, so if minus minus will become plus, this minus minus will become plus. Okay, so this is what you will get, but ultimately you will see that you will get the same answer. Solve this second part. 240 plus 80 is 320 divided by 40 is 8, multiply by 30 is minus 240. Minus 240 is equal to NB plus 80. So this implies NB is equal to minus 320. Minus 320 means counterclockwise, because this time you assumed counterclockwise is negative. So it is counterclockwise. So in the same answer we have got here. So it's depending on what you assume. Okay. Yeah. So yeah, we are at the end of the this session now. So that's all we have for this gear and gear train topics. Just to recall, what we have studied is we understood how we transmit the motion from one shaft to the other in case of gear. We also studied the different types of gears depending on the parallel shafts, intersecting shafts, and skew shafts. If we have parallel shafts, we can have a spur gear, spur rack and pinion, or helical gear, or double helical gear. Okay, and we have studied the comparison between them, especially regarding the axial thrust and the noise. In case of intersecting shafts, we can have bevel gear. The bevel gears can be straight bevel gears or the spiral bevel gears. The special types are meter gear and Zerol bevel gears. That also we have studied. In case of skew shafts, when shafts are non-parallel, non-intersecting, we can have a helical gear or the worm and worm wheel. Then we have studied the gear terminology. In that we understood the pitch cylinder, pitch circle, pitch point, pitch diameter, pitch surface, and different kind of pitch, that is circular pitch, diameter pitch, module. Okay. We also studied the difference between pinion and gear, velocity ratio, gear ratio. We also understood addendum, what is meant by addendum, what is meant by dedendum, what is addendum circle, what is dedendum circle, what is full depth of the teeth, working depth of the teeth, space width. Okay, top land, bottom land, face, flank, clearance, backlash, tooth thickness, face width, all these things we have studied when we studied the terminology of gear. Then depending on the motion of the gear, we understood the line of action, that is pressure line, angle of pressure angle, basically phi, path of contact, arc of contact, path of approach, path of recess, arc of approach, arc of recess. We have studied the formulation for it as well. We also studied the contact ratio and number of gears in contact, velocity of sliding, lob gearing, interference and undercutting phenomenon, and how we can avoid the interference in case of involute gear by providing the minimum number of teeth. Okay, and then we introduced the term of gear trains. We studied 4 types of gear trains: simple, compound, EP, reverted, and epicyclic. Okay, in simple we have one shaft we have one gear. In the compound, except the last 2 gears, intermediate shafts can have more than 1 gear. In reverted gear train, it's a compound gear train having the coaxial first and last gear. And in case of epicyclic gear train, we have non-fixed axis of a gear. Okay, non-fixed axis of the shaft of the gear, which is revolving around the axis of the another gear. Okay, and we have studied both the methods to solve or analyze the reverted gear train, relative velocity method and tabular method. In case of all three previous gear trains, simple, compound, and epicyclic, we also understood how to calculate the train value and gear ratio. Okay, how to calculate the train value and the speed ratio. Okay, so these are the major points from exam point of view. If you understand them, you will be able to solve all the problems. Okay, we'll solve problems when we come to the problem solving session. We'll just recall whatever we have studied, collect all the formulas, and then we'll start the problems. Okay, so that will be like a revision for you as well, and I find it more effective that rather than studying, let's say, a topic and then problems on it, and then another topic, then problems on it. By the time we will reach the end, you will forget what we have studied in the beginning. Okay, so as we are studying, I expect from you to go through it. So once we studied all the theoretical part and we start the problem solving, you should be able to tell me from each topic what we have studied and the formulas for it. Okay, so that we can collect it together and then start solving the questions. So that's all for the today. Thank you all for joining this class, and let's meet again in the next week. Thank you all. Bye. Have a good Sunday.
You are currently the only person in this conference.